Alright, so we'll look at question 3, which is asking us to find the term independent of x in the expansion. So the expansion we're given is x squared minus 1 over x raised to the power 6. So how basically do we handle that? So finding the term independent of x implies we have to find a term which does not have x as a variable. Alright, so we already understand the fact to say if you're going to have a binomial in this form, let's call it a plus x raised to the power n. We understand to say to find any term of that expansion, we can use a formula where you can say n and then r. You have, those are the coefficients, and then you're going to have a to the power n minus r, and then of course x to the power r. That's what it implies. So if they ask you to find, let's say, the second term, since we know that we start counting from 0, if I ask you for a second term, it implies it will be the term that is having n choose 1. Okay. Now in this case, we don't have a term that we're dealing with, so we'll just apply the same formula. Okay. Now what is our n in this case? Our n is the power 6. So we'll say what we're dealing with is 6, choose what we don't know. And then we'll say our a is x squared, which would be raised to the difference between the power, the highest power, which is 6 minus r, which we don't know. And then x in this case is negative 1 over x raised to the power r, since we don't know what r is in this case. Okay, so I can remove this part and then show that this is basically what we're interested in. So let's try to find the power, or let's try to simplify this. So here what we know is 2 is going to multiply with whatever is outside there, so that would be 2 multiplied by 6 minus r. So for basically for us to have no x, it implies the power of the x on top and the one down should be equivalent. And of course we understand that if we were to distribute the r there, x would become the power r and 1 to the power r. But 1, even if we raise it to the power r, nothing will change, so it will just be x to the power r. So the power of x, which is r, should be equal to the power of x on top, which is 2 multiplied by 6 minus r. So I'll just equate the 2. Okay, now we're going to have 2 times 6 is 12 minus 2r is equal to r. We have 12 and then r plus 2r, which gives us 12, 3 r, and then our r becomes a 4. So our r is 4. Okay, what term is that? Since we start from 0, that is like the 5th term. Okay, so these are the possible solutions. Can we prove this? Well, we can. That is x squared. Now we found our r to be 4, so it implies we put a 4 there, it means even there it's going to be 6 minus 4. And then we have got negative 1 over x. This is now also raised to the power 4. Is it the power 4? Yes, r is equal to 4, so what it means 6 minus 4. Okay, let's go. So the next step, we're going to have 6, 4, and then 6 minus 4 is 2, 2 times 2, that gives us x to the power 4, and then we've got negative 1x to the power 4. If we were to distribute the power, negative 1 times raised to the positive power to an even power gives us a positive 1, and then over x to the power 4. So you can clearly see that these are going to divide, and hence this clearly proves that to say this term is going to be independent of x. Okay, so apply the same concept to answer this one. Alright, so I'll just go direct to the point since we already know what to do here. So we use our formula n. Our n in this case is 8. So 8 r, and then we've got 3x, which should be raised to the power 8 minus r, and then we also have negative 2 over x, which should be raised to the power r. Okay, we know where we formula where this is coming from, right? I've already indicated to say nr. If you have a, it will be n, and then the other one will be, you just fit the power r, and that's exactly what we've just done. Of course, this is in a case where you have a plus b raised to the power n. This is how you find the term in the binomial expansion. So feel free to pause the video and just try this one out. So of course we're interested in the power of x, so that's going to be the power of x. So that will be x is to the power 8 minus r, and then for this part that will just be x to the power r. So if we distribute, if we equate the powers now, 8r being equal to r, 8 is equal to 2r, and then our r also becomes 4 in this case. So equally r is equal to 4. Okay, you can prove if you want. Same question is repeated. So you will have 8, choose r, and then we have 2x in the brackets raised to the power 8 minus r, and then negative 3 over x to the power 3 raised to the power r. Feel free to pause the video and try this one out. So for this part, x will be raised to the power 8 minus r. The other part, it will be this 3 times that r, so that will be x to the power 3r. So that's going to be 8 minus r is equal to 8r, and then 8 is equal to 3r plus r there, and then that gives us 8 is equal to 4r, and then r becomes a 2. So therefore, it's r is equal to 4, which we can call the fifth term. Simple and straight. No, actually, r is equal to 2, which can be called now the third term. Okay. So this is basically very simple and straightforward, right? Just understand that when they say the term independent of x, it implies a term that doesn't have x variable in the expansion. And of course that occurs when you've got a variable on top and on bottom. And so at the point where their powers are going to be equal, they will divide. Okay, let's look at question 6. This is very simple and straightforward. We'll just get into it. So we want to show that the left is equal to the right hand side. So I'll start with the first one. So we have n0 plus n1 plus n2. So I've been looking at these questions and it's taken me weeks. I just look at them. I don't know how to handle them, but today I just sat down and said, let me try to answer them, and then I just discovered this is very simple, and I thought it is. Yeah. So even in exams, just because you've never seen a question doesn't mean that you can't solve it. Okay. So I don't know how to manipulate the left hand side, but let me manipulate something that looks easier. Since we are dealing with binomial expansions, I can express 2 in terms of addition. So our right hand side is equal to 2n. Now 2n is the same as what? 1 plus 1, right? Raised to the power n. Let's try to use the binomial expansion to expand that. So our right hand side becomes, we know the first part will be n choose 0, and then it will be 1, n minus 0. Remember, we're still using the same formula, that is, if you're going to have a plus b raised to the power n, okay, the formula is, for any term it's n choose r, and then you understand that a will be the difference and then b will be to just the power r. So that's what we're trying to do there. So n minus 0, 1 to the power 0 plus n choose 1, 1 n minus 1, 1 to the power 1, n choose 2, 1 n minus 2, 1 to the power 2, plus dot dot the final term, which is n choose n, is going to be 1 raised to the power n minus n, and then that will be 1 raised to the power n. So you know that is 1's raised to any powers, they still remain 1's, right? Okay, so this will just mean that we're going to remain with n choose 0 plus n choose 1 plus n choose 2 plus until we get to the last term, which is n choose n. So we can now see that the left hand side has become equal to the right hand side. So left hand side is equal to right hand side, hence shown. Now with the basics that I've given you, you are now at liberty of looking at the last one. Yeah. So now the last one is dealing with a bit of some subtraction here and there, and so we can just edit this one slightly. There is a negative, there is a plus as it is, and so what we have is a minus, an addition, a minus, again a minus, 0. This one I didn't even try it on paper. This is, I was just trying to think of it as I'm hoping it works out the same way that the first one has worked out. So feel free to pause the video and try it out. I can give you a hint. When you've got a 0, think of it as expressing it in terms of an addition, in terms of binomial. 0 can be expressed as 1 minus 1, right? So our right hand side is equal to 0. 0 is the same as 1 minus 1. Now I'll bring back the power n, right? Okay. So what does that, how does that come out? How does it come out? So if we try to proceed in the next step, we'll see n choose 0. And then the first part will be 1 will be raised to the power n minus 0. And then the other part, which is now negative 1, as we can see from the expansion there, negative 1 will be raised to the power 0 as well, plus n choose 1, and then 1 raised to the power n minus 1, negative 1 raised to the power 1, plus n choose 2, 1 n minus 2, negative 1 raised to the power 2. Now you know that any time or every time that you raise a negative to an even power, the answer is always a positive, right? And so we understand that is going to give us a positive, and then essentially after that positive there, the next part is going to be an odd, which will be a negative, and that's where that dot is coming from, and that will continue exchanging until we get to the last one. Okay. So obviously that's what we expect. And then n choose n. We're going to look at that. It's going to be 1 n minus 0. And then here you understand that for the last one where we have negative 1, now in fact that's not n minus 0. It will be n minus n for the last one, n minus n. And then you have a negative 1, which is going to be just the power n. Now of course the last one is dependent on the value of n that you're dealing with. It's an even power, odd, that will determine the sign, but we'll just assume, or it remain the way it is, in other terms. So what we have at this point, you can see for the first part, again we've already emphasized to say 1 raised to any power, it just remains a 1. But now the negative in this case is playing a different role. So negative 1 raised to the power 0, now that is a positive. You have to be careful there. So that would be n0. For the second one now, where negative 1 is raised to the power 1, that clearly gives us a negative. And then n choose 1. Then this one, negative 1 is raised to the power 2, so that gives us a positive n2. Now the next number obviously after the second term, the third term is going to be a 3, which is of course an odd number, and a negative when we start number, we are going to get a negative, and this will continue swapping. That's what this implies: negative dot dot negative, and then n choose n. So now you can see that the right hand side equally in this case is equal to the left hand side. And so that's it for question 6. Very easy to show. Just try to understand what's given on either the right and the left, and which one are you able to manipulate easily. That will help you make a decision on what you need to focus on.